AP Physics, Day 4, page 86 or 87 or 88, problem number 53. Here's a purely symbolic problem. And once again, with a lot of these kinematics problems, or any problem in general, a good diagram helps out quite a bit. Now this one in particular, you got to be very careful with your notations. S sub r stands for the range of the projectile, how far along the horizontal ground, or assuming level ground, the projectile lands from its initial spot. It's basically its horizontal, its displacement. Then we have an initial launch velocity v sub I at an angle, let's call the angle theta, and we have the components of the initial launch velocity. So we have v initial horizontal, vi sub h, and then v sub iv, initial vertical launch velocity, which are independent of each other. Those are the important aspects of projectiles. The horizontal and vertical components are independent. So the general idea with all symbolic problems where we really don't have numbers we're dealing with is use good notations and then try to use known equations. For example, we do know that horizontally speaking, like any projectile problem, there is one equation. And the one equation involves three quantities: v horizontal, s horizontal, and time horizontal. But specifically in this particular problem, using the carefully noted diagram, the horizontal velocity in this problem is v sub ih. S will be s sub r, the horizontal displacement, which is what we're really looking for, and t we haven't labeled yet. We'll just still call it t. But that's what connects the horizontal to the vertical motion. The time is the same time frame. So vertically, let me go back to horizontal for a second. The equation that goes with the horizontal is just v equals s over t. That's the generic form of the horizontal motion. It's constant velocity, but specifically to this problem, we have v sub I h equals s sub r over t. Or if I rearrange that right now, because I'm trying to get to what the problem wants me to prove, that s sub r equals some expression up there. It's negative 2 v sub ih times v sub iv over g. But you can almost see it taking form already. In other words, s sub r, if I solve this equation, s sub r, is going to be v sub ih times t. So the bottom line is I got to get rid of that t, and it's going to turn out that t is going to be obtained another way in the vertical. Here's the generic statements. For example, we have v, here's what we've done generically, v sub I, v sub f. These are generic to any problem, a, s, and t. So in this particular case, if we have a projectile launched horizontally like this and it lands at the same height it was launched at, excuse me, the initial vertical launch is v sub I v. Okay, so don't let that red v sub I, that's not particular, that's generic for any problem, but the black v sub iv is the vertical velocity for this particular problem. V sub f, when the projectile lands, if we're assuming no air resistance as we are here, is on a flat surface always the negative of v sub I v. In other words, if you launch something with an initial velocity of 20 meters per second upward, it will land with a speed of, or velocity of 20 meters per second downward. The acceleration is g. That's how that's going to enter into the problem. We don't need to plug in 9.8 for that. S will be 0. If we're taking our launch point, point A, I'll label that with blue, and your landing point, point B, for our conditions here, for the horizontal and vertical motion, this vertical displacement is 0. The horizontal displacement is s sub r. And t is just still t. So what I want to do is find an equation, any of the four uniform acceleration equations, and you can almost use any of them, but some are more useful than others. We want to have something that has the v sub i's, the g, and the t, because, well, especially t, because we got to get rid of the t. So, well, how about the first equation? Generically stated, the first equation is v sub f equals v sub I plus a t. Now if we put the particulars in for this problem, I'll switch back to black. V sub f is negative v sub I v equals v sub the particular for this problem is v sub I v for the initial launch velocity plus g times t. And now if you're good at algebra, you can see this coming together. Basically, you're going to solve that, rearrange it, solve that on the right hand side here for t. I don't need to see all the steps. There really are two steps. You're going to move the v sub I v to the left hand side and then divide both sides by g. And if you do that, you get negative v sub I v minus v sub I v all over, g. All right, that's two steps in one there. And then if you go one more step here, because we have negative v sub I v minus v sub I v, it's negative 2 v sub I v all over g. Now you can see this coming together. I'm going to take that expression for t, this thing, I'll circle it in blue. If I bring it over here into t, I'll let you do that. That gives you the final answer we're looking for. In other words, we proved that the range of the projectile is going to be v sub I horizontal times that negative 2 v sub I v over g. That's what was the objective there at the top of the page. Congratulations. So let me recap one more time. When you do these symbolic problems, what you really want to do, diagram is very useful. Be careful with how you label things. And then use known equations to put in the particulars, the generic equations, plug in the specifics, and rearrange things algebraically to come up with what you're trying to prove.